All right, here is the momentum review worksheet video. I'll try and go through this as quick as I can, and good luck tomorrow on your test. So the first question, two cars have different weights. That means they have different masses. Oh, I don't want it to be blue. Change it to red. So different masses. They're traveling on a level surface at different constant velocities. So the two cars have different momentums. There's M1 V1 and there's M2 V2. Within the same time interval, so T is the same, greater force will always be required to stop the car that has greater. Okay, so we're talking about force, and in this unit, basically when you see force, you better be thinking about impulse, which is Ft, and that equals M delta V. So the question becomes real easy when you look at it that way. If the time is the same, if that time doesn't really matter, I guess is one way of saying it, greater force will be required, not based on mass, not based on velocity, but the combination of the two, which the combination of the two is momentum. So the greater force will always go with the greater momentum. So answer A is correct. You can't say velocity because you could have a small velocity and a large mass, and you don't know what they are. It's the combination of the two. Same thing with weight. That's why that doesn't work. And kinetic energy, you could come up with a time where that would work, but again, it's the square term screws things up with the M and the V. Just think, you could have something that's really small, but's going really fast, so it's going to have greater kinetic energy, whereas the momentum might be smaller than if it was a large mass with a small velocity. So use your impulse momentum theorem. It's a pretty difficult question, though. I mean, it reads like it's easy, but it's actually pretty difficult. So take your time on that one. Next question. What is the speed of a 1,000 kilogram car that has a momentum of, I crossed it off here, I think it's, what is it? 2 times 10 to the fourth, so it's 20,000. P equals mv. You have P, you have M, you're just solving for V, so V is P over M. 20,000 divided by 1,000 is 20, and this is also testing your scientific notation ability, I guess. So answer A was correct there. All right, the next question. You have a 0.05 kilogram bullet fired from a 4 kilogram rifle that's initially at rest. So that's key here. It's initially at rest. So that means your P before is equal to 0. Okay? If the bullet leaves the rifle with momentum having magnitude of 20 kilograms per second. So in this explosion, you have a bullet going this way with a certain amount of momentum, P of the bullet, and you have the gun over here. That's an awful drawing, but the question is, what will the magnitude of the momentum of the rifle's recoil? So the rifle is going to go back with how much momentum? If it's 0 to begin with, this and this have to be summing to be 0 after. The only way that can happen is PB equals negative P of the rifle. So, or basically this plus this has to equal 0. So they tell you what that is. They tell you the bullet is 20 kilogram meters per second. That means the recoil is 20 kilogram meters per second. You can apply this to ice skaters if you want to. That's a common explosion question where one ice skater goes off with a certain amount of momentum. The other ice skater has to go off with the exact opposite momentum. I might ask you to, figure out what the M and V are going to be after. So, like the bigger skater would have a smaller velocity, the smaller skater would have a greater velocity type of thing. All right, next question. Diagram below shows two carts that were initially at rest. Again, initially at rest means P equals 0. Being pushed apart when a compressed spring is released. So it's an explosion. the first thing I think of is the momentum this way has to equal the momentum that way. Again, because P before equals P after, 0 equals, writing 0 doesn't help, it's really P of one object plus P of the other object, or P1 equals negative P2, which is basically what I was writing here. Equal and opposite momentums. So the momentum of cart B, we don't know what the velocity is. So the momentum of cart A is 3 times 0.33, and B would be 5 times, I should say negative, kind of implied because the arrow here is in the opposite direction, 5 times VB. Is that what they're asking for? The approximate speed of cart B. So this is 1, 5 times 0.2 would be your answer. Or, I mean, solving for VB, I guess you'd divide the 5 over. And VB is negative 0.2. Keep the negative sign. They're asking about speed, though, and speed is a scalar, which means we don't care about the direction, so we just take the absolute value of it. So the answer is B. Next question, almost identical. It's a spring that's released, and you have equal and opposite momentum. So the momentum here would be 3.6 kilogram meters per second, 2 times 1.8. And the speed of the 1.2 kilogram block would be, you do m times v, so it would be 1.2 times v equals 3.6. It's pretty simple math. 3 is going to be the answer for that one. Next question is talking about what's the unit for impulse. Take your time. Impulse is force times time, which would be Newton times seconds. No. Okay, so you don't make it up and pick this one because it's got a Newton in it. You say that J is also equal to delta P, and P is m times v. So the unit for that is kilogram meter per second, which is answer C. All right, that's the first one done. Another 7.5 minutes.